Here in the Harp area again, had some crazy big whumps. Probably the wildest whumps I've ever experienced in my life. Probably at about 3,100 feet on a southwest aspect right now. So from right here, I just remote triggered this avalanche right up there. You can kind of see the debris. There's a safe way to get up there, so you gotta take a closer look. Check out that huge crack from this remote triggered D2 persistent slab. This avalanche was remotely triggered from about 3,050 feet on a southwest aspect. The propagation traveled uphill at least 300 feet, and it produced this very, very widely propagating D2 persistent slab. So two bowls right there. Just noticed down here in the gully, this killed someone's dog in 2016, I believe. There is debris from probably a D2.5, likely natural avalanche that ran maybe at the beginning of the storm cycle Thursday night, since it's been blown over and filled back in a bit. But this avalanche ran 2,000 plus feet to deposit that debris there from these starting zones. So here's a little better view of the extent of that remote triggered persistent slab. We got some localized active wind loading, as you can see over there on the Temptation and Coctoya ridges. Some naturals on Harp. Looks like 3 to 4 separate ones. Maybe some sympathetic triggers in there. I'm here at the apex and thickest part of the crown of this remote triggered D2 persistent slab avalanche on this southwest aspect at about 3,300 feet in the Harp area. Two bowls right there. Almost looks like 3 separate hard slab layers here. You can see this top one peeling off, but at the base here, we have some really, really loose facets. We have this one finger wind pack layer with a thin layer of extremely loose facets on top of this very low friction crust. Cracks have radiated out at least 50 to 75 yards in that direction where the slope did not slide. I'm here at the toe of the debris, definitely large enough to bury, injure, or kill a person. About 2,900 feet, 250 degree west aspect, 28 degree slope. You can see that remote triggered D2 persistent slab avalanche up there. Just dug a snow pit here. And we got about 105 centimeter height of snow, which is not a bad snow depth for this time of year in the South Fork area. Dug an extended column test. And I got an ECTPV down 30 centimeters. Again, you got 3 simultaneous fracture layers. One down 10 centimeters, the next down 15 centimeters, and the bottom one, which is the same that produced this persistent slab, down 30 centimeters. So here at the top, we got 1 finger plus wind pack layer. Then there's a density change where there's this pencil hard wind pack layer, another density change right below that, then 1 finger plus. And then there's that very loose, thin, faceted layer on top of this old crust.